Today we are going to move forward to software part. So we will have a lab today. And we're gonna introduce you to these four types of software. R is free. M+, yeah, it's commercial, but it's installed in all of these computers. And EQS, I believe that they installed that too. Amos, let me see, Amos, I'm not very sure. So yeah, you can check your computers to see. No, Amos is not installed. Okay. So if you are not familiar with programming or software, that's okay, because I'm gonna do the software demonstration here. I will just teach you from the very beginning, from the very basic part. So first, let's look at R. The developer of R is, yeah, the R core team, and it's developed and also maintained by all volunteers. So if you have your own package, you can just upload it to the website and you're gonna maintain your package. And the operating systems, including the Mac and the Windows, okay, also Linux. Yeah, it's very powerful. So basically, it's very flexible, very powerful. You can do whatever you want. It's very, yeah. And the type is for statistical analysis and also graphics. Graphics are also very strong. So the big pro of R is it's free, it's open source. So you can just see their you can open the package and see their functions. Okay, so you can check the details of some procedures. And the language is based on S and S+, so it's very flexible. That's R, but now we are going to use RStudio. RStudio and R are actually the same thing. RStudio just kind of like an interface. Okay, so we have the background R is running, but the original R is not user-friendly. So RStudio just add another surface, and we can just do a lot of operations based on the RStudio. Okay, but the core part is still R. So it's an environment for R. I just give you the RStudio, the interface of the RStudio. So we have 4 panels here. So I'm gonna introduce these 4 panels. This panel is for the edit. Okay, so, oh, okay, so yeah, this is for edit. Okay, so let's, yeah, we will go back to these slides again. So we will gonna see all of these panels. And how to install R. So you can, if you have your home desktop or laptop, and you can just download R from the website, and also download RStudio from their website. Okay, you can just type R, download, then you have the website and RStudio, and also download that, and just install that software. It's really easy. Just follow the instruction of R and RStudio if you want. You can also check those YouTube videos. Okay, it's very, very simple instructions. And for Mac, yeah, and we also have some video. Yes, if you have any question, you can also use this website, and a lot of people can just answer your questions. And we also have our help meeting list. So R is not kind of like, not just like SPSS. SPSS, you do not need to write your code. Okay, so you only need to click some buttons. But R, you need to write your own script. It's called a script. It's kind of like it's coding language. Okay, there are some commands, functions for you. Don't worry about that. Okay, I will give you all the R code, and you can only modify part of that, and you can have your own script. So as I described here, we have 4 panels here. This panel is for you to write down your script. Okay, and I have my script, and I have already uploaded it to ELC. You can just download that part. If you open that script, it's automatically shown here. Okay, this is kind of like a command panel. And then this part is called console. So after you run something here, this is command, the result will be shown here. Okay, so these two panels. And here it's about background related information, for example, package. So you're gonna use some package. Our package is a set of functions. Okay, so after you install a package, so a lot of functions will be available for you. So information of the package and also plots. So if you wanna plot your data, okay, you're gonna show some plot graphs. It will also shown here in this panel. And help, yeah. So if you are not very sure how to use some specific function in R, you can just type in help or question mark that function, and automatically the details, usage, the parameters, the related information, okay, the examples, all of this function related information will be shown here. So, and this panel also give you the background information, for example, the detail, the log information or the data information, global environment, some history steps, something like that. Okay. So first step, you're gonna create your own script. And of course, you can open the existing script and then do some edit. Okay. And you can run those commands from the console directly. So here we have 4 panels. You can save your some commands here and run them one by one, or you can just directly run the commands here from the console panel. But after you run if you want to do the console part, okay, so run the commands directly here. You didn't save your script. So next time, if you want to repeat that part, you have to type in again. But if you save it in your script, then you can just copy paste. You can just run it directly. Okay. So it's suggested to use a script part, the R editor part. Okay. And also you can just save and change, delete something. Yeah, you can change all of these commands and save something and modify something, edit something here. It's just your file, it's just your script file. And yeah, so you can edit your command in the script part, but after you run it, you cannot just edit your commands. It's already been sent. Okay, it's already in the console part, it's just run the command. Okay. And if you want to explain some functions, for example, I may give you a lot of code functions. So if you are not very sure, if you cannot understand the meaning of that, you can use the pound sign to show, okay, to add some comments. Add some comments in the beginning of the function or the end of the functions. So when R meet the pound sign here, they will not just run the command for you. They will just repeat their part. It's because the R knows that it's a comment. Okay, it's not a command. Okay, let's go to the details of the R script. It's very, very important. So that's why I put it in the first screen. So R is case sensitive. Case sensitive. So what does that mean? If you give a value to a variable A, the capital A, then that's only for capital A. If you're trying to type lowercase a, the R will give you back some information. Okay, I cannot find anything here because you didn't give me any number for lowercase a. So capital A and lowercase a means different objects, different variables. So you have to make sure. For example, if you have really long variable names, for example, SEM course, but if you put a C, course is a capital, then after several steps, you also want to use this variable. So you use the SEM course with a lowercase, no. So the R will not recognize different the name, okay, with different case. So it's very, very important. So you're gonna do your exercise, and sometimes you might meet some errors. So you need to go back to check what is the information, what is the error message. And they will give you some hint. Okay, so if the message said, okay, this object does not exist, or I cannot find this file. So you need to check the name again. Maybe it's just due to the case, okay? Yeah, typo is a common mistake for beginner, for our beginners. So let's look at variable names. So you have, so okay, so for R, you need to put some values to some variables. So you're gonna decide to use some letters or numbers to name your variable. Okay, so but there's some rules. You cannot just give any type of name to variables. So for example, a valid variable name can have letters, numbers, and the dots or underline, something like that. But not all the combination of these will work. So for example, if you use capital A, that's good. Okay, any letter, any kind of letter, you give a name, you give a value of 2. So A equals 2. So that means the A variable equals 2. Next, if you type capital A, automatically it will return 2. Okay, because 2 is the value of the capital A. And then you can also use capital A plus any number. Okay, for example, 1, then it's valid name. So you can also give a value to this variable A1. And of course, okay, we have 2 letters A, B. Okay, that's good. Okay, and we have 2 values. A dot, okay, a capital A or lowercase a or any kind of letter, and a dot, it's also valid variable name. So you can give value of 2. A underline, okay, it's also allowed, just like this. It's also allowed. And of course, you can add another letter after the underline, okay, or after the dot. It's okay, it's fine. And dot A, look at this variable name. Okay, I start with a dot and then a letter. It's still okay, okay? So dot A or A dot, okay? And the dot on the line. So this looks very, very weird, right? But still, it's a valid variable name. You can use this to give a number, okay? But look at this case. If you start with a number 2A here, okay, A1 or A2, it's okay. But 2A or 3A or 10A, that's not allowed. So you cannot just give any value to a variable named 2A. Or underline capital A. Underline, no, okay. Start with an underline capital A, no, not a good variable name. And here, okay, so dot A is good, okay, dot A, but dot number, dot 5, no, it's not a good variable name. So there are some rules. So you can just try to use the combination of letters, numbers, and dots and underlines, but not all the combinations will work. You can just try most of them. But basically, we will just use A or a number. That's it, okay? Or A, B, C, some characters, some letters. That's it. Most cases, people just use these cases. I think it's kind of like maybe we can just do it together. Maybe we can just, let's just open R first. Okay, so I will show you how to open R Studio. So here, after I type R, so we have R Studio. So just click R Studio here, or you can just directly search R Studio. And then there's a blue circle with a letter R inside, then click that software, okay. So here, that's your R Studio. We have 4 panels, okay. Okay, so that's the first step. You have your R Studio. Now, please go to ELC and download a file called, I think it's called R Lab or Lab R. So yeah, go to R Studio, go to ELC. It's called the lab underline R.R. Okay, .R, the file is an R file. It's a script, R script file. So if you go to ELC and find the course. So course content and today's course. Okay, so Lab R is a name, and it's .R, it's R file, it's a script. Okay, so download this file, save it to your local folder. Okay, save it to a folder, to a desktop or your own folder. And remember that path, because we are going to use that path again. Okay. Suppose I save it to here. Okay, I save it to my own path here directly. And then you are going to click file. Okay, so from our studio, we have so many menu buttons. Okay, so we have file, we have edit, we have code, view, plot, session, build, debug, profile, tool, help. So the first button, the first menu, so file, click that button and then open file. So there are a lot of like options, new file, new project, open file, and new column, recent files. Okay, so we have a lot of like options. Just click open file. Now you're gonna find your folder, which save your R code, R file. So you just save it somewhere. You just save it, download the R file and save it to your own local folder. So you're gonna go to that folder, okay. And then you're gonna choose your file. For example, here, okay, I have my file here. Then automatically, I have the R script file opened here. Okay, just ignore there are 2 red cross because yeah, I just gave you the demonstration that these names are not valid, but please ignore these 2 red cross. And then when you look at this R script, some color is black. Okay, you have some fonts are black, and we have gray, we have a blue. All of these are good. Okay, these are good. But of course, we have some mistakes here because this is the invalid variable names. Yeah. So if you want to look at this, if you look at this script, so in the very beginning, I put a lot of like a pound sign here because all of these are my comments, the description. So I will just totally ignore these lines because these are comments. The green part, they will just ignore this part. And then we have session info. Okay, this is just information of this session. So you can just highlight this part. Okay, the good part of our script is that you can just highlight the part you want to run and then click run here. There's a button, there's a small button. Okay, it's called a run. Highlight the part you want to run and click run. So the console will automatically repeat that command here and give you the return the result. Okay, so after you highlight session info and after you click run, so we have the results from our, so our version 4.1.0 and the flat 4. Okay, the window, it's not Mac. And
you can also do Control Enter.
You're right. Yeah. Control Enter is also the same as run. Okay. Now we are going to, because our actually run all of this command in working directly. There's a directory to save all the results, the current results. So you can change your current working directory to the folder where you saved your current R file. So you're gonna change because by default, R has their own working directory. But the R file has been saved to your own local folder, for example, your desktop or other place. You're gonna change the default working directory to the current working directory. So how? Here, there's a session, okay, in the button menu. So there's a session button. Click the session, and then there's an option called set working directly. Okay, set working directly. I think I can make this larger. So and then make it
it's under global settings.
Previously, we installed some software here, and we can zoom it very large, but I forgot. It seems that they have already deleted this. Anyway, just click the session here on top of the menu bar. There's a session, and one option is called set working directly, and there are 3 sub options. So the bottom one is choose directly. So you're gonna choose your own directory. So after you click choose directly, it just gives you, okay, where's your folder, where's your working directory, your new working directory. So again, you're gonna go to the folder you save your file. For example, in my case, I just use this folder. That's one way. You just click those buttons and choose the working directory. Another way, just use a command. Okay, just like the command here, set WD. Okay, I also give you an example. This is my example. Okay, set WD. What's WD? Working directly. Okay, short for working directly. You're gonna set your own working directory, and then in the parentheses, it's a detailed path of your folder. Okay, so for example, in my case, is a G disk and the folder teaching and also the course of this the SEM. But it's not. It's my folder. You're gonna change it to your own. Okay, you're gonna change it to your own folder or working directory. So this place should be the folder you saved all your data file, your command, and in ELC I also uploaded some different Excel or .txt file. So all of these should be saved here, okay, in the same folder. And then here I give you a lot of like examples for variable names. The first part is the exercise for case sensitive. So I have the first command, 1 goes to capital 1. Okay, so I highlighted this part and click run. So here in the console part, I give a value of 1 to the capital A. And then in the console part, if I type capital A, you can try to type capital A, then it returns 1. It automatically returns 1. That's good because 1 is the value of the capital A variable. But if I type lowercase a, then I got error message. It said object A not found because I didn't give any value to lowercase a. I just gave a value to capital A. So the R code is case sensitive. Okay, so the following part, you can do your exercise. Okay, just follow because that our interface is too small. I don't think you see anything here. So I will just use the slides here. Okay. So anyway, these two parts, the commands are the same. So you can just do the exercise. You can just type in or choose the R command here in the script and just run. For example, you can just, sometimes you can just highlight a bunch of commands together. Okay, here I just highlight all of these rows, lines, and then click run or control enter. Okay, then automatically the results are shown here. So you just, the console part just repeat what you have already run. And then if you type any type of variable names here, it just it will just give you the value of the variable. Okay. For example, if you want to check the dot underscore, then it returns 2 because it's already success given name. And then you're gonna try these wrong variable names. For example, 2a, 2, a letter and plus a letter, a number plus a letter, 2a is not allowed. But pretend that you're trying to run this part. Okay, click run. So the error message is that unexpected symbol in 2a. So this is not allowed. And same thing, you can also try to give a value of underscore capital A. Okay, and highlight them and click run. The same error message, unexpected input in the underscore, okay, on the line. So these are not allowed. And also dot and
Trying to interrupt for a second.
oh, you want it? Okay,
Go up here to profile.
okay.
Sorry, see, we're looking for global options,
Make it larger.
just in appearance,
Good, thank you.
and then there's your font size.
Okay, I will make it very large. 76. Okay.
And that should increase it. There you go.
Oh, good, thank you so much.
Sorry, I had to refresh it. It's been years since I did it.
Yeah, so you're right, yeah.
Size does matter.
It's much better. Thank you. Thank you so much. Thank you.
Sorry.
Maybe I can make it even larger. Oh, this is the maximum.
36 should be large.
36
Yeah.
is the largest one. Okay, I cannot make it even larger. So, but this is big enough for us to see in the script. So we just checked all of these wrong variable names and nothing returned. Okay, so there's an error. And also this part, there's an error message. And also dot plus some number. Okay, it's also error. You cannot use this as a variable name. So that's an exercise of variable name. So do you have any question? I hope that everybody has opened the R, has the script ready, okay, in the R Studio, and then you can just follow the steps. Okay, now let's look at some basic operations. Previously, I just tell you how to give a number to a variable, but R, the powerful part is that we would like to do some operations, okay? So the basic operation including plus, okay, the multiplication, division, the power, okay. How are we going to do that? Suppose I have several variables, A, B, D, E. How are we going to give value to those variables? You can use equal sign, just we did before in the previous slide, just equal sign, that's good. You can also use this, okay, the less than symbol and dash or hyphen, okay, the minus actually. So this actually goes to, that means a 2 goes to A, 2 goes to A. It's another way to give a value to a variable. Or you can use the other direction. Here, 4 goes to D, okay, a minus sign and the larger than symbol here. So the 4 goes to D. Sometimes you need to input a vector, not just one number. For example, I want to assign a vector to variable E. So 1, 2, 4, 5 are 4 numbers. So I can use C to connect them together. So C parentheses and 1, 2, 4, 5 together was given to the variable named E, okay? And then you can do a lot of like a basic operation, for example, plus. So we have A value, we have B value, and the plus. Then we have 5 returned. And the multiplication is this one, okay? Just like little star here, and do the multiplication product of A and B, and it will return 6. And also we have the division. So the sum of A and B, parentheses, and then divided by D. So it will return the results. And here it's a power, okay? E and this symbol tell us I'm gonna square that vector. E is a vector, so a squared vector. Each element inside of this vector will be squared. So the returned value will be again a vector, and it's 1, 4, 9, 25. Okay, so you can just do the exercise. So go to the R Studio. Yeah, so these are different ways to input the data. You can just highlight all of these. Choose highlight, okay, and the control enter or click run. Okay, either way, it's the same thing. Okay. If suppose you click run here, okay, now you have A, B, D, E assigned. And in the console part, if you want to check those variable values, you can just type in A. For example, here, after I give a value to A, so I just repeat A. Then the R returns 2. So that means the A value is 2. Okay. And you can also, for example, you can just type E. The lowercase e is a vector. So after I type E, return. So it returns 1, 2, 3, 5. That is a vector of E. And next part is for basic operation. So plus A plus B. Okay, you can just click run. So A plus B is 5. A times B. Okay, A times D, 6. And a division. Okay, it's the sum of an A, B divided by B. So that's it. Because B is 4, and the sum is 5. Okay, 5 divided by 4. Okay, and E squared. Okay, and it just give the squared vector of E. So 1, 4, 9, 25. Okay, so here I mentioned a vector. We can also do further operations based on this vector. It's called a concatenate function because it's short for the C is short for this function. Okay, so just connect all of these numbers together and we have a vector. So this is a direct way, but sometimes we also use a very, very short way in R. For example, 1 to 5. So here, so in this case, 5 number from 1 to 5 will be given 1. So create a vector of consecutive integers from 1 to 5. The smallest one number is 1, and the largest one is 5. Increased by 1 digit. Okay, and y equals 1, 2, 3, 4, 5. So you can just do the exercise in the. Oh, this is another exercise. Okay, you can just. Yeah, you can go to the line of 65 and 66. So check the X here for vectors, vector operations. Highlight this part, click run. So that's your X. Okay, X is 1, 3, 2, 10, 5. That's it. Okay, this is your vector. And if it's a vector created by 1 to 5, then you can just type 1 here. Okay, type Y here. So it returns 1, 2, 3, 4, 5. Okay, this is one way to create a consecutive integers. It's very easy. And then you can do basic operation. For example, Y plus 2. Then each element in Y vector will be increased by 2. Okay, so add 2. So here, Y plus 2 is 3, 4, 5, 6, 7. Okay, and the 2 times Y. So 2 times each element in Y. Okay. So this is a 2 times Y. And Y squared, raise the power to 2. Okay, squared. Each element will be squared. Yeah. Okay, now here, let's look at this. 2 to the Y's power. Y is a vector. Y include 5 numbers. So 2 to the vector. Again, it will be a vector. So each element, so you can just see the number here. Okay, 2 to the Y's power. So 2. So here, this is a power. This is a power. Okay, so 2. Raise the power to 1. It's still 2. 2 raise the power to 2. Okay, squared 2. It's 4. And the 2, the third power becomes 8. Again, the 2 has a power of 4. The fourth power is 16. And the fifth power, okay, 32. So that's the meaning of this function or this operation. Okay. Okay, so let's go back to these slides. Yeah, we have already done. Yeah.
For the, just wondering for the typing, for the multiplication, could you also put y times 2 or does it have to start with a q times y?
Yeah, you can do the exercise by yourself.
No, I meant like the, right, for the scalar multiplication, how in your example, it's your code is 2 times y.
2 times y.
Yeah, right, yeah, number 70.
Yeah.
Can it still work if you said y times 2? Like if you were to switch the coding?
It
I guess,
should
yeah, I
work,
could try that
yes.
one myself.
Yeah, you can just do the y times 2. It should be exactly the same because the multiplication doesn't care about the order. Okay, yeah. Yeah. R is very flexible. You can just do a lot of like exercise here. If you have some typos or if you mistyping something, it will just return an error message. And by reading those error message, it will give you a hint. Okay, where should I modify my code? Or where should I change the code? Yeah. Okay, so that's vector. And we can do more. Okay, so about vectors. For example, this is a vector of weight. Suppose I have so many participants. All of these participants have the weight listed here. And I'm gonna put all of these to give a vector named weight. So weight includes so many people's weights or actual weight numbers. So after you run that function, so if you type in weight, automatically the R returns this value, this vector for you. So that means the weight is a vector including all of these numbers. Okay. And then of course weight plus 3. So each element inside weight will be increased by 3. Okay, plus 3. And then, okay, this is tricky. Weight has so long, okay, so many, how many? I don't know. So maybe 8. So elements here. But here I add a vector, another vector with only size of 2. This is a small vector, 1, 2 only. The length is not the same. The weight, it's really long, but here we only have 2 elements. And then let's look at that. Okay, so the first element plus 1, the second element plus 2, and then it's gonna automatically repeat this for you. So the third element plus 1, the fourth element plus 2, and then plus 1, plus 2, plus 1, plus 2. It will just repeat because the size, the length is not the same. And also let's look at this part here. Okay, weight larger than 100. Weight is a vector including a lot of numbers. Larger than 100. Actually, it returns binary outcome, yes or no. It just tells you if the element inside of the vector is larger than 100 or not. If it's true, then it just returns true. If it's not, it returns false. No actual number. Okay, it's just 0, 1, 0, 1. Actually, it's true, false, true, false. For example, the first element here, the weight, is larger than 100. Yes, it is true. Okay, and 170 is larger than 100. Yes, it returns true. This one true. Okay, true, true, true. But here, okay, let's move to this element. 95 is not larger than 100. So this statement is false. So it just returns false. And also we have true, true, true. Okay, so this one is also false. Okay, 100. 100. Is 100 larger than 100? No. 100 is not larger than 100. So it is false. This one is false. Okay, yeah. So it just gives you a comparison. So it's very, very useful. Sometimes you need to do the comparison. You don't need to care about the actual number, but the comparison is true or not. Okay, true or false, true or false. It's very useful. So go to, if you want to do the exercise, go to our studio. Yeah, so the order, the script didn't follow the order in the slides, but it doesn't matter. Okay, you can just highlight this part of the exercise. So this is the weight. Okay, this is the weight. We have weight. Yeah, question.
Well, I was just gonna, I'm curious to wonder, why do you highlight everything?
I choose that part, and it's automatically a highlight.
Well, what I'm saying is if your cursor is on line 84 and you don't highlight anything, go up one line and now hit run.
And the control, you can also use control enter.
Right. But
Yeah.
I'm
Or some-
lazy. I don't like.
Yeah, but sometimes I try to highlight these two parts. Yeah,
Correct.
because sometimes I try to only run this part and run it together. For example, square root width. Okay, then I just run all of these three commands together.
Okay.
Then just click one once. So
Right.
all these three commands will just run once.
Simultaneously.
Yeah.
Gotcha.
So weight plus 3 square root read. So each element inside weight will be square root. Okay, so these are numbers of the square root of the weight. And then weight plus this value and the weight larger than 100 or not. Okay, so that's an exercise. Okay, so let's move forward to the okay, now let's look at the data input part. So far, we just manually input some value to some variables. Okay, you just manually do that. Enter variable name and give a value. But suppose you have a huge data set. Okay, you cannot manually type in these numbers. So you're gonna use your reader data. So you're gonna import the existing file to the R file, input the R program. So how to importing data into R from other type of file? Yeah, we have already covered this part. So if we have the manually typing C, okay, so it's already there. We have already covered this part. You can also use a function called scan. Okay, scan is very basic function. Okay, so for example, if I go to the R Studio, you can just highlight this part to try to run. Why there's a 3? I don't know. You can just delete this here. Why there's a 3? And then, okay, so that's just wrong. Okay, so we have given the codes here. Okay, just type in scan. Okay, maybe it's not here. Maybe it's in the data part. I don't have scan part here, or maybe in the beginning part. That's okay. So you can just assume that we have variables, for example, x. Okay, and then you're gonna give some numbers to x, and you can use a function called the scan, and then parentheses. So every time, so this stop. If you have this function, so the R stop and waiting for your input. So it's an interaction part. So after typing scan and it returns 1. What is the first value you want to input? And then you type in one number. And then automatically it goes to the second one. It is stop there. And you can type in the second value and then stop there. After you finish typing everything, you can just type return again. So it automatically just report all the numbers you just input. Okay, for example, we can just do the exercise. Okay, the first value. What is the first value? We can just give a big number, for example, 5, and then typing return. Okay, enter. Then what is the second value? it just asks you again. So suppose 6, so you can just return. So you just repeat this part and just stop here. For example, I stop here. Oh, because I type in the S, this is not actual number, so there's a mistake. Sorry. So just give some numbers, whatever you want. And after you finish everything, just return. So these 5 numbers will be saved to X. Okay, X is a vector, so you can just type in X again to see. Okay, X is a vector of these numbers. And sometimes you're gonna change. Okay, this is a change data set. So if you type in some vector here, but if you want to change the vector, for example, this means the second position. Okay, this is a vector. This is vector we defined here. The second position, these 3. Suppose this is a typo. I want to change it to 2. And you can just use a correct number goes to the position of this vector. Okay, the D set is the second position goes to 2. And then if you check the D set again, so it will be updated version, just through the updated version. And the next part is for matrix. Okay, we have already looked at the scalar part, the vector part. How about matrix or array? Okay, so we have several rows or several columns together. Then there's a function. Okay, so in R, it's very flexible. There are functions of matrix array. So suppose we are going to use array. So this is the data we're trying to input. This is a matrix. We have 2 columns. We have 5 rows. So how to input all of these numbers in one command? Okay, so we're gonna use array, and then these are numbers. Okay, these are numbers. And let me just talk about the dimension first. Okay, the dimension of this array or the matrix is C5, 2. What does that mean? So the dimension is 5 by 2. 5 rows, 2 columns. So these 2 numbers tell us how many rows, how many columns. This is the dimension of this matrix. Sometimes you will also have 3 positions. Okay, you have different matrix together. So I will not confuse you. So suppose that it's just two dimensions, 2 parts. Okay, so we have 5 rows, 2 columns. That is a structure. That is a dimension of this X matrix. And these are actual numbers. Okay, but how to arrange those numbers? Please remember, in R, it's very important. It's column first. Column first. What does that mean? So this is a framework. This is a dimension. How are we going to put all of these numbers inside of this matrix? Column first. I'm gonna fill in the first column first. Okay, so 5 goes to here. 7 goes to this position. The first column. Second element. 4 go to the first column, third position, and the 3 and the 8, and stop here. Okay, because we have 5 rows. So these 5 numbers from 5 to 8, I already filled the first column. Then I go to second column. Okay, the 3, okay, this 3 goes to the second column, the first element, and then 2, 4, 1, 9. So column first. This is in R. You have to be you have to be careful that for some other software, it may not follow this rule. Or also you can change this rule, but by default it's column first. For some other software, it may row first. In that way, the way to read this number becomes 5, 7, 4, 3, 8, 3, 2. Okay, it's different. Then the outcome is totally different. By default, again, R is a column first. Of course, you can change it to other way, but these are other story. Okay, so So you can try to do the exercise in the R script. So where is it? I'm sorry, I didn't follow the same order in the script. So you need to check your code. You need to find the did I include these commands in the R script? Did I include it here? I didn't see any. Maybe I didn't include this part. No. Here? No. Okay, I didn't include this part. Then you can just copy it from your slides and oh, it's here. Okay, yeah, it's here. It's here. Okay, so here this is X array, and we have the dimension 5 by 4. Okay, and then if you type X, now let's check X again. That's it. This is our output. This is our result of X. And you can also use matrix. Okay, so suppose this is matrix and the non row here. This is the parameter. Okay, all of these are called parameter. So this is function name. In R, we have a function name and the parentheses. Inside the parentheses, there are a lot of parameters. You can change the value of parameters. For example, this is a parameter. You can change these numbers. This is a parameter name, and you can change these names. Okay, this value. So if you are not very sure how to use this function, you can just type in here in the console panel. You can just type in, for example, array. Okay, so I want to see the function of array. So automatically, the right panel here it just gives you the description of this function, the parameters. Okay, so the arguments and details. It's very convenient for us to check the function and details, value, note, and examples. Okay, reference. So you can just follow the examples here. You can just do the exercise. So same thing. Okay, so suppose you are not familiar with the matrix part, then you can just type in question mark. Yeah, question mark. Add a function. It will give you the description of that function. Okay, so suppose you are not familiar with this function, okay, matrix, then return. So this panel provides you all the details, description of this function, okay, matrix. So suppose I just want to do the exercise of Y. Y is a matrix. Number of rows. Okay, n row. Okay, here n row means number of rows. Again, it's column first. So all of this number will fill in the first column. And the number of rows, 5. After I have 5 numbers, I stopped. I'm starting the second row. I'm sorry, second column. And after I have another 5 numbers, I stop there. I start with the third column. So n rows is the number of information matrix, and you can just highlight this part and you click run and check Y again. So if you type Y, that is your Y matrix. 5 rows and yeah.
So this is the first function. Doing the same thing.
Yeah, but now I'm gonna change the way to fill in this matrix. Here, I change the by row equals 2. So let's do this again. Let's try to repeat this part again, but I add another parameter, by row equals 2, to see what will happen. Okay, so I highlight this part and the run, and then I type the Y again. Now, let's look at the results. It's totally different. Okay, let's look at these two. Let's look at these 2 Y. I repeat everything here, but I add another parameter called by row equals true. What does that mean? I change the default setting. The default setting is column first. Now it's row first. So let's look at the Y. The 5 goes to here. 7 is the row, the first row, and then 4 here, and then 3 here, and 8, 3. So this way becomes row first. I have to fill the row first. First row, second row, third row. By default, R takes the column first. But if you really want to change this way, it's okay, it's fine. You only need to change the parameter of by row. By row equals true, okay? That's very tricky part. So again, R has a lot of like hidden functions. By default, it follows some ways, but if you check the details of the function, you can change a lot of like default setting. So this matrix is different than this matrix, totally different. It's totally different. The first column, okay, this first column is totally different. Second column, but the same number. All of its numbers are the same. Okay, now, okay, I just show you different ways to enter data, input the data manually. You can use the assignment, you can use a scan, or you can use the matrix or array. But now let's go to formal. Okay, so we have a bunch of data. We have a huge data file. Suppose this is the ID, this is gender, college, GPA score. I have a lot of students. Then how are we going to read the data file into R? It depends on the existing file format. Suppose this format is text file. Okay, so we have text file. It's called gpa.txt. Then you can use this command called read.table. If your data file is .txt, the text file, the plain text file, you can use the command read table. I'm gonna show you the other way. For example, if you have Excel file or the SPSS file or SES file, how are you going to use? You're gonna use different command. Okay, so for text, it's read table. And here we have some parameters, or we have some options. So options. A string, what does that mean? So if you have missing value, so if a missing value, mark that 999, then yeah, it treated as missing value. Sometimes you have missing value, okay? And the header equals true. What does that mean? So I have a table head in this case. I have a table head, ID, gender, college, GPA. Should I include the head or not? If you want to include the head of the table, then yes. If you don't want to include that one, then you can just use false. Okay, so header equals true or false. And this is actual file. You can save your file in the same direction. Then you don't need to give the direction. That's it. This is a file name. But if your file is saved in another folder, in another directory, you have to change the directory in front of the file name. You have to give the specific file, the location. Otherwise, the R don't know where is the file. Okay, so my suggestion is that all of this data file is available in ELC. Okay, go to ELC, download that file, and save it to the same folder, same place, same working directory, so that you don't need to change the directory here. Okay, so save it to the same place, then directly put a name, the file name here. And okay, so after you read all of this data file, you're gonna give a variable name. All of this is saved to an object. Okay, object name or variable name, GPA, whatever you want. Okay, this is just name. You can just say my GPA or SEM exercise, something like. Okay, so whatever you want to name it. Okay, so if we go to the R Studio. Okay, so this is the next part description. We can just check the, let me see, the read. Sorry, I didn't follow
Is it one
yeah, it's here. Okay, GPAs, yeah. I didn't follow the same order, so you can just check the line of 135. Okay, so we have GPA is a data file. Okay, by using the function of read dot table, this is a data file, and all of this data file gonna be saved to GPA. This is the name of the object. And the header equals to, I want to keep the header, the table header, okay. NA string 999. So this is a missing data indicator. So it depends on your missing data indicator. So sometimes you have NA, sometimes you have 999, sometimes you have kind of like a negative 444. So it depends on your actual data. So if you want to look at the GPA text file, it's here. Okay. This is the actual file. This this is a GPA.txt. We have first column ID column, gender, college, GPA, weight. Okay, so the first individual, it's a female, and yes, college student. GPA 3.6, weight 110. Okay, the second student, and here we have 10 records, 10 pieces of records, and then I'm gonna input the information into R. That's my text file. So I have read the table ready. So highlight this part and then click run. Oh, error. Text file cannot. It's not here. It's not here. Cannot open the connection. No such file. Is it here? It didn't.
It has to be in the same directory as your.
Oh, because it's refreshed. Yeah, after I increase the font, it just
No,
goes to the default. Not here.
No, your working directory hasn't changed.
Let's just try to find the file. I saved my. Okay, so previously it didn't find anything in the current working directory because I didn't set the working directory. The file is not saved in that file. So now I change it to my own folder, and then I'm gonna repeat it again. Okay, if you're trying to repeat the previous one, you can just put the upward arrow. So you're gonna repeat the history command. For example, this one is the one I want to repeat it, and then return. And now it's ready because there's no error message. There's no error message, that means it's successful. Then you can check it, GPA, okay, GPA. You can check this this data file.
Yeah, it also shows you up in your
Yeah,
top left.
yeah.
Right.
So now we have the table. Actually, the data set is stored here, GPA.text. I have ID, gender, college, GPA, weight. But here I don't have any comment. Okay, so let's check the original data file. Okay, this is my original data set. I have some comments. Okay, this is my GPA data. And if I have 999, for example, here. Let me just make it clear. So this is the original data file. I have some 2 rows comments, and then we have the table header. Okay, and then the actual information. And here I have some 999. 999, what does that mean? So that means this information is missing data. So I don't have anything recorded here. This is missing data, missing data. I don't know the GPA score of that students. Okay, so here we have 999. In that case, you're gonna tell we have some missing values. So here, NA3999. So if you meet any number equals 999, that means that is the missing data, missing value. Missing value in the R means NA, not available. Okay, then that value is not available. Missing value. So let's look at the table here. This value originally it's 999. It's 999. But in R, because R use NA to indicate the missing value, so it becomes NA, not available. Missing value here, missing value here, missing value here, missing value here. Because I don't know the actual GPA score of those students, student 3, 4, 5, and 10. And the table header, yes. So I keep the table header here, and this is the actual data. So that's a function of read table. That's only for the text file, okay? So for different format, we may have different function or command. So I will show you the next format. Okay. So let's look at the CSV. So suppose the data file is saved in the format of CSV, okay, comma separated variable, okay. Then you're gonna use read.csv, not read.table. Okay, so if your file is something .csv, then you're gonna use read.csv. But actually, the output is quite similar. Okay, the default. Okay, and if you have some tab, okay, if you have some data file separated by tab category, okay, delimiter is tab, then you're gonna use a function called read.delete, okay, delete, and they will automatically read the file separated by a tab character. If you want to read an Excel file, okay, so you have Excel table and .excel. If you want to import that table, you are going to use a package, okay, called RODBC, okay, and then library. So I'm gonna show you how to install a package and use a library. Use that package and then install that package first, and then use the library, that package name, and then convert the file to CSV, because originally it's Excel, and then you're gonna convert it to CSV and then use the read.csv. So finally, you import the data into R. Sometimes you may have your data saved in SPSS. Okay, it's also very common. Then you're gonna use a package called a foreign. Okay, so again, you're gonna install a package called foreign and then use a library foreign and then use a read.spss. Okay, so the actual file name attached in the parentheses, so you can read in that. You can also use a package of foreign to read the data from Minitab, SS, SATA, database. So we have many ways to read the data. So let's go to the file. Let's go to the RStudio. The next part is access to data. So this is the actual operation of GPA data file. Let's skip this part first. We have some, yeah, suppose we have the Excel data called the CSV. Okay, it's saved in the format of CSV. Then you can use read.csv instead of read table. And that object, okay, that is a table will be saved to an object called Excel data. Okay, so this file is already it's in VLC. You can try to download that file and save it to your current folder, current working directory, the same folder as this code. And then yeah, check it. If you check one data file, it's here. Okay, so if you want to check the Excel data. It's saved here. I just manually type in some numbers here. It's very short. It's example. So we have 2 columns. We have 5 rows, 2 columns, just 1, 2, 3, 4 to 10. Okay, this is an example. And then I download that one, save it to the folder here, and trying to highlight this part. Just run these 2 columns, two lines. So it's already imported to all. So in the Excel, I'm created a CSV file. Okay, 1, 2, 3, 4 to the 10, and that's it. And if you want to read SPSS data, and I said, again, you're gonna use a package called a foreign. So how to install a package? Okay, this is very important. So one way that you're gonna use this command, this function called install.packages. You should not miss this S, because this is very easy for you to miss the S, and there's an error message. Okay. Install packages and then parentheses. What is the name of package? Automatically, the R will run installation for you. You can also use this panel. Okay, so if you go to this panel, but now I cannot make it larger because I don't know how to make these numbers. I don't know how to view it. No, it's not.
Packages.
Yeah, I cannot make this fonts larger. I only changed this part, okay. But anyway, there are different tabs. So we have different tabs. We have file, we have plot, we have packages, help viewer. So if you click package, the third tab, under that tab, you have 2 options. You have one is called install, the other one is called update. Okay, we have 2 actions. So if you click install, then it asks you what kind of like a package you want to install. You type the name foreign, for example, in this space. Okay. And after you type in the name and you click install, that's it. But I don't want to install it because I have already installed this package. Okay, so if you want to use this package the first time, so it will ask you to install it. But once you install that package, you don't need to do it again. So because I have already seen all of these packages are listed here, all of these. Okay, so I see that there's a package called foreign. I only need to check. Okay, check here. We have some boxes. Okay, we have boxes in front of each of these packages. I check this package automatically. It have a function called a library. Of course, you can also manually type in library that package. So what does that mean? So after I installed that package, after I use library, this package is ready for me to use. Okay, I can use any function inside of that package. Otherwise, if you don't use library, that package, you cannot just run the function inside this package. After you type in the function here, it said, I don't recognize that function. I don't know where is this function. You have to attach, kind of like attach. Okay, you install that package, you have to attach that package. And then all the functions will be available for you. Okay, the first step is installation, and then second step, library. And then it's ready. Yeah, yeah, you can also run this part. This is the same thing. Manually use this function, or just click those buttons and check those packages. It's the same thing. Okay. And suppose I have an SPSS file called airline passengers.sav. So if you want to check the data set here, okay, this is the data set. It's also uploaded to ELC. It's called airline passengers.sav. So I'm gonna show you the actual SPSS file. So it's gonna take us it will take us some time to open SPSS. It's not fast. Or you can just, highlight this part. The R is much faster than the SPSS file. So you'll highlight this part and then click run here. So it's ready immediately. Okay, this is the file of airline passenger.sat. Okay, that's it. We have different airlines, we have different passengers. Okay, now SPSS is ready. Okay, so let's check the original data set. This is the original data set, SPSS file. And we have just one column. The column, the name is number, the passenger number. So from the first airline to 144 airline. Okay, so we have one column number. And this is SPSS format, but by using the read SPSS automatically, it's in R now. And you can check, okay, so there's a function called head. Head just show you the beginning part of this data set. For example, this data set is really large. There are so many rows. Sometimes it's not convenient for us to just scroll down and scroll up. So you only need to check the beginning part. So highlight this part. Head, the data set. This data set is called airline because I have already saved all of this file to airline. Beginning part of this huge or really long data set, and then that's it. It just gives you the information, the format. Okay. You can also use names to check the column names of this data set. Okay, names and click run. So here we only have one column. The name is called numbers. Okay, number of passenger. That's it. That's it. Okay, so this is the exercise of reading, import the data file into R. I think we can stop here for a break because we're gonna continue the command. We have a lot of that exercise. Yeah, we can just stop here and have 15 minutes break. Thank you.
Just trying to open the electricity, but it is it's in or
I don't have the update R.
Yeah. So, you already solved the point.
Kind of like
I should. You can retrieve it.
It's not so.
like
They force us to use it in my department so much.
over the summer, I tried to use artist compilation house. I spent another 2 weeks trying to figure it out, and I gave up. And I just went to another program. 2 weeks on one analysis. That's really ineffective. So that's not productive at all.
I mean, it's one of those things that's all or nothing. You have to use R for everything in order to be comfortable enough with it and be able to do anything like that. I'm gonna go downstairs and use it. I hope you want to do that.
Are you not allowed anything in the program or you have to?
Well, one of the forestry is just so much for. Instead of doing the rows and columns, I was just- it's not how they work at all. So do you have a code for a license for us on SPSS or no?
SPSS?
Yes. No?
I think all the computers here is available. But if
And
you
it's on
want
the virtual
to
lab also.
install it in your own computer, I think you can just request the COE. I think they have some license available for us, but
Oh.
you have to request.
Mhm.
Yeah, because
might
I
do
think
that.
it's campus-wide available. You can also use a VLab. There's a VLab and to run.
Yeah, that's
this
what I was
alone.
running, VLab
Yeah,
earlier.
yeah.
I'll have to request that then. Thank you.
But based on my experience, because I haven't done this year. Based on the previous experience, I don't know if they changed the policy or not. Yeah, because there are some different versions of.
It's usually, they
SPSS.
probably
Yeah.
did.
Okay, so we just talk about different ways to import the data to R. And we can do a lot of like exercise. For example, okay, suppose this is my GPA. We can use name, this is a function to take out the column names. Okay, what are these, or table header or column names? So they will return the column names. Dimension, okay, GPA, how many rows, how many columns, so they will automatically report the information for us. Head, the beginning part of the table. Sometimes we have a huge table, for example, more than 1,000 rows. So if you just want to check the whole table, gonna take you really, really long, and you cannot go back to the history to check the other results. So you can check the beginning part only. So use head. Also, you can check the bottom part, the final lines, final information. Then use tail. And Okay, so in the table, we have so many columns. We have some columns. If you want to specifically check out the information of specific columns, so you can use $sign. Okay, so GPA is the whole data set. GPA, the data set, $sign, and then the column name. Gender is just the one column inside of the table. So I use $sign. All the information, all the value of gender will displayed after you run this command. And also you can use attach. Okay, so GPA is a table, and you can use attach. When you use attach, all the columns are available, automatically available for you. You don't need to use $sign. Okay. And then here, if you want to take out some element, particular element from that table. So this is a table name, and here, break. Inside of the break, we have two positions. First position tells you which row. Second position tells you which column. So by combining the row and the column, you identify the specific element. For example, this one, okay, is element located in the third row, second column. And then the element, the value will be reported, will be returned to the R. And this column, okay, this example, GPA is a table, and the first position is blank. I don't specify any row information, but I want to specify the second position 1. So what does that mean? I want to take out the first column. This is the first column. The column first, row blank. So all the information, the elements in the first column will be recorded. And here, GPA is again the table name. And the first position 1, second position blank. So I want to look at the first row in that table. The first position tells the row information. The second position is a column information. So here, this is one element located on the third row, second column. Here, this is the first column of the table GPA. Here, this is the first row of GPA table. So you can check out, you can verify this command in the R Studio. So go to R Studio. So we have GPA as a GPA data set. Okay, so I'm sorry, I combined a lot of things, information, and one manuscript. So GPA is here. Okay, so we have GPA ready. So you can just try to run this part again. So names, okay, names, check the column names here. It returns ID, gender, college, GPA week. We have 5 columns. These are table header. Okay. So that's a function of names, and then highlight the dimension, div. Okay, div, and click run. So we have 10 rows, 5 columns. This is the dimension 10 by 5. That is a matrix GPA. And then head. Okay, the beginning part of the table. So it only gives you the first 6 rows, lines. Okay, so we have ID, a column. Okay, all of this. The first 5, the first 6 students information. You can also check the tail part, the end of the table. So here, the tail part, again, 6 students information are listed here. And then, okay, now I'm interested in the gender. I'm interested in this column only. I want to take out the column gender. So use $sign. GPA is the table name, and then $sign gender. Let's see. Okay, that's it. This is a column of gender. 10 people. So 10 values of gender: female, male, male, male. Okay, females, all of this. And then if you use attach, so you can also use attach GPA. So this GPA is available, then you can just directly use gender. So you can just directly use gender. You don't need to put a $sign. if you don't use attach, if you just say gender, it said, okay, I don't know this variable name. I don't know what is gender. But after you use attach, all columns inside that table will be directly available for you. Okay. And you can also check the elements. For example, okay, the element inside the GPA. Okay, so 3, 2. So let's check the head. The head is at the beginning part of the GPA. So I'm gonna look at the information, the element, the third row. Okay, second column. That is M. Okay, so first row, second row, third row, second column. This is first column. Okay, this is the information provided by R. This is not actual information inside the table, GPA table. So don't mess with this, the first column. This is the first column. Okay, this is not first column. And this is second column. This is the third column, fourth column, fifth column. So the first row, second row, third row, second element is M. That is element we identified by using the GPA 3.2. Okay, that's it. This one, this number. So that's why I put the GPA 3.2 is M. You can also check the first column. Okay, first column of GPA. Then that's it. This is ID. Okay, from 1 to 10. This is the information of this column, not this column, not this column. Okay, this is the first column here. Then you can also check the first individual's information. First row, okay, first row. And that's it, okay, first row. ID 1, gender F, college yes, GPA 3.6, weight 110. That's it. Okay, it's quite easy for us to identify the specific elements in the matrix or table. Okay, now let's look at missing values. Missing values are very important in our practice data and also in R. Previously, I showed you, okay, in the original data set, I have some missing values. The indicator, the missing value indicator is 999. And then after I import that file into R, so the places with 999, marked with 999 becomes NA. In R, you have to use NA to show that is a missing value. If you directly import the original file into R, you didn't indicate the missing value is 999. Then the 999 will actually treat it as an actual number. That's not correct because the GPA is 999. It's not correct. Okay, so you have to tell R which value is missing, and you have you have to use some indicator to show it. So anyway, in R, the missing value is marked as NA. And after you region the file into R, you can check the GPA column. So that's one column. So this is the output of the GPA. So we have some missing values here. I don't know the GPA scores for those students. And then let's check another function. There's a function called is.NA, and then the information here, the GPA is the GPA column in the GPA table. So we have column and table here. Is.NA, again, it's for comparison. Is a return value, it will be true, false, or 1, 0, 1, 0. So it tells us if that value is missing value or not. Okay, so the first one, it's not missing value. It has actual value 3.6. So it is false. So this asks you, is this value a missing value or not? If it's not, then it's false, returns false. And then if this value 3.5 is a missing value, false. Then NA, now we have missing data here. NA, it is a missing value. So if this value is a missing value, true, it is, yeah, 1. And is it NA true, okay, false, true. Okay, that's very important in R because in many cases, if you don't deal with missing data correctly, it just return a lot of like error message. So you have to pay attention to this NA. Yeah. So in R, if it's true, then the actual value is 1. The underlying value is 1. If it's false, then it's 0. Okay. So we only have 2 outcomes for comparison. For any kind of comparison, previously we just compared the weight larger than 100 or not. It's another comparison command. Now, okay, so we can just do the exercise first. Okay, we can go to our studio. Okay, so we can look at the NA. So GPA, $ GPA, then we have this column. And is that a missing value or not? So it returns yes, true, false, true, false. Now let's look at the data subtraction. I have already mentioned some of the examples for you. Okay, so for example, this one is taking out the first column because the second position is 1. Okay, second position inside the brackets tells us the column information. The first position tells us a row information. Here, the row information is missing, it's blank. So I don't care about which row. So all rows are available. I just want to look at the first column. Okay, first column, all rows are available. You can also take out the specific column with a name here. Okay, that is a number of columns. First column, second column. Sometimes you don't want to count because there are so many columns. You can just take out the gender. For example, it's one. So located in the 15 columns. So you can just put the name, the column name here, and it will take out that information. Here, this is the first for the first row. Okay. And here, okay, here is a combination of 1, 2. It's a vector. The first position, it's a row information. Row information is a vector. What does that mean? I'm gonna take out the first row and the second row. First row and the second row, 2 rows together. Okay, 2 rows. Of course, you can change it. Okay, 5 rows or 10 rows, or choose specific rows. 4th row, 5th row together, combine them together, pick them. Or I can use a name. Okay, a row, the column named friends and the column alcohol. Just take these 2 specific columns out. Okay, these 2. So it's column. And I can save it to personality. For example, these 2 columns combined as a new data file called personality. Or you can use this one. Okay, the 3rd column and the 4th column, take out these 2 columns, combine them together to create a new table called personality. Okay, it's very flexible. Or I can use 1 column only, just friends, 1 column. Okay. And here we have another very important command in R called cbind. Cbind. C means column. What does that mean? I'm gonna combine several columns. Cbind. Column bind. What kind of column I want to bind? The data set, the data 1. Okay, this is the data set 1. The friends column, that column. This is 1 column, and the data set, the alcohol column, 2nd column. I combine these 2 columns and I call it a matrix 1. Okay, so we have different ways to take out those columns and the rows or elements. So let's do an exercise in R. So data 1, where's the data 1? So data 1, I have, I think I have already saved it somewhere. This is for weight. Okay, so go to line 223. Actually, I have a lot. Okay, so data set 1, it's this data set. I just try to read a different format, format. So this is for data set 1. And this is for data set 2, a different file. data set is 3, 4, and 5. Just check the data set 1, data 1, data 1. It's a table, a data set for lecture data.csv. And again, this is available in ERC. Download this file, save it to your current folder, and use this command because this is CSV. So you can try this command, read.csv. And also include a header. Okay, so let's check what is lecture data CSV. So it's here, it's okay, the Excel file. So that's it. This is an Excel file for lecture data. We have name, first column, we have birth date, second column, we have job, we have friends. Okay, number of friends, we have alcohol, we have income. We also have the personality column, neurotic or not. Okay, so we have some points for them. So anyway, this is our lecturer's data and the .csv. We use the command read CSV to import the file, and that's it. This is the whole data set. We have 10 rows, and that's information. Yeah, you can check it again. So that's it. 10 students, Ben, Martin, Andy, birth date, job, 1, 2. I remember the job tells us if that a professor or student, I think of that. Let's look at income. Yeah, 1 means name the professor, but this is an older data set. So these are quite low. And then we have 2 main students and alcohol for every week, maybe 10 cups, something like that. Okay, friends. Okay, how many friends? Okay, so for students, there are a lot of friends. But for professors, they are quite lonely. Okay, so several friends here. So neurotic is something like that. So we can just try to do the exercise based on this data set. Data one is a name. Then first column. Okay, I'm gonna take out the first column. First column is name. Okay, all the participants' name will be shown here. Okay, that's it. First column. And then third column. Suppose I want to look at the job situation. Third column. So highlight this part. Third column. Okay, yeah, just 1, 1, 2, 2, 2, 2. That's it. And then, okay, I specifically want to check the name column. Okay, this is a name column, or you can just replace it with birth date or job. Okay, you can just replace it with income. So suppose I'm interested in the name column, which is the first column, and it is good again. So if I want to take out the income part, or birth date. Okay, birth date. So the second column actually. So that's the information on the second column, the birth date of this participants. And we can pick out some columns. For example, I'm interested in the column of friends and alcohol. So just pick out these 2 columns and use C to combine them. These are columns because the first position of the matrix is blank. And you can highlight this part. Wrong. That's it. Okay, 2 columns only. Personality has 2 columns only. And then you can, okay, also you can use the column names or column numbers. Okay, third column and the first column together. Okay, and I call it personality. So let's try to do it again. Okay, then this is a third column, job, and first column, friends. This is a new data set. And if you want to look at the first row, okay, then first row, that's it. That's Ben's information. First two rows, I'm into the first two students' information. So 1, 2, combine them together. So we have Ben and the Martin's information listed here. Suppose I'm into the second participant, second participant, and what did I do? Second participant and the fifth. Okay, then I can just use this one to pick a Martins and the Grahams. Okay, so the fifth participant. And this is for the first row, fourth column. Okay, first row, fourth column. Let's see what is the information. Oh, what did I do? Let's see what's the information here. It's just 5. Okay, first row, fourth column. Okay, friends. Okay, it's 5 friends. 5. That's it. Okay. And yeah, of course, you can also try the C bond. You can just try the C bond command here. Column bond and the highlight and the brown. So check matrix 1 in the console. You can try to check the column of friends, column of alcohol put together.
Alcohol.
Alcohol, yeah, yeah. So that data is for drinking, the drinking behavior, something like that. Personality related, career related. Okay, so let's look at another part. It's called the logical values. Actually, we have already talked about the logical values. We compared the weight with 100. We also compared the missing value or not. So for any type of logical values, the outcome is true or false. Just 2 outcomes, 1 or 0, yes or no. Okay. Suppose we want to use these 2 symbols. Okay, so equal sign twice. If it's 1 equal sign, that means give a number, give a value to that variable. But if I put 2 equal signs, that means it's a logical value to do the comparison. If that vector is an M or not, it just do comparison. For example, gender, I have 10 genders. So it just each element inside of that vector will be compared with male or not. For example, the first one is female, so it returns false. The second one male, so it's true. Okay. The third one is male, so it's true and true. And this is a false. This is a female, so that's why it returns false. You can also count how many are male. So some. Okay. So male. So the true is 1. Okay. So the false is 0. So the male, the number of male actually can be counted here. And you can use sum. Sum is a function to get the sum. Okay. To get the value of all of these vectors. Sum of gender equals male. So I want to know how many people in this vector is male. So sum is 5. So that means there are 5 males. Okay. And also weight. We can do the comparison. So the gender is male. For those participants, I want to take out the weight information. So here, I just specifically pick the male, and then these informations are for male participants. So that's only for male group. So you can just partially choose the value from the table, okay, from the data set. Okay, we have already gone through a lot of operations here and the read table and yeah, pick out specific columns and rows Let's look at the descriptive statistics. Descriptive statistics are also very important because you're gonna use this function a lot. For example, you have two vectors, okay, x and y. We have summary, okay, what is the minimum, what is the maximum, we have a lot of information. We have length, okay, how many elements inside x? X is a vector. Range, what is the minimum, maximum, what is the range? Okay, also minimum, maximum, mean. Okay, what is the average of the vector? What is the median of that x? What is the variance? What is standard deviation? Covariance between x and y, correlation between x and y. So all of these are very important, okay, for our descriptive statistics. So you can just, yeah, you can also do the descriptive exercise for GPA or for grade, for gender. Yeah, so let's try to do the exercise in RStudio. We have basic operations. It's moving the earlier part. Yeah, here. Okay, so we have x. Suppose this is our x. This is y. This is y. We have two vectors. Let's look at this x. X is 1, 2, 3. Okay, 1, 2, 3. Let's check y. That's 1, 3, 2. Okay, y 1, 3, 2. We just imported the value here. Now, what is the summary of x? Okay, let's look at what is the outcome of summary. Summary of x, the minimum value, the first quarter, the median, the mean, third quarter, and the maximum value. So it just gives you the summary, the 6 values. Minimum value 1, okay, first quarter, median, okay, third quarter. And the sum, what is the sum of x? So 1, 2, 3, what is the sum? So we turn 6. Then how many elements in x? So we have 3. Range, okay, from the smallest value to the largest value, 1, 2, 3. Minimum, what is the minimum value? What is the maximum value? And what is the mean of this x? And what is the median of this x? Standard deviation and the variance. Sort, okay, sort x, sort, rank this x from the smallest one to x, but it's already sorted, okay, because it's 1, 2, 3, so it's already, yeah, in that order. Square root, okay, function, square root, so take a square root of 1, 2, 3. Covariance between x and y, correlation between x and y, yeah, so that's a basic exercise for descriptive statistics. Okay. So let's go back to the slide. And yeah, also you can do the exercise for weight or for other variables. Now let's move forward to a little bit more complicated case. So let's look at the model. Suppose we want to run a model in R. How should I do that? Again, we have many functions. If you want to run a linear regression model, LM is that function. LM is short for linear model. Okay, regression, because linear regression is one submodel of the linear model. Okay, and then this is function. Inside of the function, after the function, we have parentheses. Inside of the parentheses, you need to specify which variable is your dependent variable. Okay, here, the first variable is your dependent variable. And then you have a tilde to tell R that which one is your independent variables. Okay, so after tilde, that variable is your independent variable. Of course, you may have different independent variables. So you have x1 plus x2. So you may have a very long. But this is a really simple case. We only have 2 variables, one y and one x. Before tilde, the y is a dependent variable. After tilde, the x is independent variable. That's it. Yeah, so LM is for linear model. Yeah. So it's gonna run a linear model, linear regression for you. And there are two related functions which are very important. You can use summary and then put this inside the parentheses of the summary. The summary parentheses and then inside the part linear model. So let's see what's also the second function is ANOVA. So let's try to look at the summary first. Okay. So we have already covered this. We have already covered this. Yeah, I'll give you a lot of exercise. So if you have time, you can just run all of this one by one. Okay, here. So this is we have x shown here. We have y here. And suppose I want to check the linear model between x and y. Y is a dependent variable. Okay, run. Ln. That's it. This is a returned result. I'm gonna call linear models. The formula, the model here is y tilde x. Y gonna predict, I'm sorry, x gonna predict y. And here, it's really simple output. It's just coefficient, intercept, and x. What does that mean? This is A, this is a, because for linear regression, the key point is we want to know what is A value, intercept, what is the B value, the slope. And if you just run linear model, the result is very simple. That's it. This is A, this is a B. No P value, no the standard deviation, no other comparison. So we can try to use summary to get more information. Okay, so summary, linear model. Now you see that we have the coefficient, standard errors, P values. Okay, so let's. Okay, so again, call that function. We also have some residuals for each observation and coefficient. Here, this is the coefficient table. We have intercept. That means this is A, the A value, the intercept part. X is a slope. B part. This is estimate of B, and the standard error of A, standard error of B. T value, the ratio of these two, T ratio for A, T ratio, T value for B. Probability, okay, it tells us if A is significant or not. The P value for B. So it's much detailed information than the previous LM. And also we have the residual standard error on first degree freedom. Okay, we also have F report. We have the degree freedom, multiple R square, adjusted R square, F value, degree freedom, okay, P value. And then you can try ANOVA. So it will return the ANOVA table for you. ANOVA linear model. So here we have the ANOVA table with X between part, within part, residual with degree freedom, sum. Okay, sum squares of the between part or within part, mean square between part or within part, F value, F ratio, probability. And you can see that the results are the same. Okay, so F probability, P value here, the F value here, and degree freedom, this freedom here. Okay, so we have two important outcomes for linear model. Linear model. And if you are not familiar with the function, again, use a question mark LM to check the details. Okay. And that's a exercise. Yeah, I just give you the screenshot of these two functions, summary and the model. And also the calculation, the basic descriptive statistic screenshot. If you have multiple regression, then you have more than one independent variables. So how are we going to handle that case? How are you going to set a model in R? Just linear model. Why? Again, the dependent variable. Now I have two independent variables, x1 and x2. Just use plus sign to connect them together. Okay. So you can also check summary and ANOVA table to look at the output of multiple regression. Okay, so you can also do exercise. I have already that help. Okay. It's not included in the script, but you can just do the exercise by yourself. Okay, just copy that command. Create 3 columns, Y column and X1 column, X2 column. And let's look at the other functions. You can create your own function. You can write your own function. You can also do your plot, do data plotting, figures, histograms. Okay. Yeah, so next week we will see the SEM. We will see a SEM package. It's called just SEM. Okay, so we're gonna use that package and do a lot of like SEM data analysis. So this is a simple question. This is a simple function created by our script. So manually, you can just create a function just like this. To have your own function, and then you have your own package, and allow the other people, to install your package and use your function. So this is an example. So this is the name of function, and the function is by default is built-in function here, and inside of the parentheses is information you needed to input. Okay, inside of that function. So suppose this is the data you input the X variable. So first you needed to know what is the sample size. Sample size, use length function, and then you save it to n. N is your sample size. And then you use the raw score of X minus the mean. This is a function, mean, the X bar, okay, mean of X bar. This is a deviation score. Deviation score, and you square it, and then get the sum, and then divide by n minus 1. This is a definition of variance. Okay, so by doing these steps, you create your own function to calculate the variance. Of course, everything's coming from the definition of the variance. So after you save it to R, next time you can just directly call this name, function name, my variance. And then after you input the information of the X, so the variance will be calculated immediately. This is your own function. Okay. And you can also plot your data. Okay, so not tomorrow. Okay, so not tomorrow. So next week. So we will have some SEM data. So histogram, for example, histogram. And let's try to look at the example. This one. Suppose we have the airline. Yeah, so airline passengers is a very long vector. So we can try to plot the data by using the histogram here. Histogram, I have already saved the airline. Let's try it again. From SPSS. We entered, okay, then histogram, this, the column name is number. Main gives the title, okay, the title of the histogram. This is a title. And also you can give the actual label for X and Y. So here, this is X label called number. So You can highlight this part and try to click run. Here, that's it. This is a histogram of number of passengers for airlines, for different airlines. Okay. Histogram is kind of like a density function. Okay, so it just roughly give you the density function. All of these are number of passengers. And we have some distribution of these numbers. You can also plot your data by using the plot function. So that's it. Okay, here we have number of passengers plot. Okay, we have a lot of like airlines and how many passengers. Yeah, that's for graph. And yeah, for package, actually I already mentioned in the first session, in order to use any function inside a package or our package, you have to install the package first. That is the first step. And then use library to attach that package, the package name here. Okay, this is a built-in function. And then you can use a function inside that package. Okay. So next week, as I mentioned, we're gonna use a package called SEM. SEM is a package name. And there are a lot of like functions inside that package. So we are going to do a lot of estimation. Okay. We will run linear regression, multiple regression. We will rerun the previous examples and to see the outcome from the package.
Is that in the package library database?
Yeah, I will do the demonstration next week. But if you want, you can also, yeah, you can just try install the other packages and print this SEM. SEM, just structure equation model.
Right.
So this is a slide for install and use our package. You can use menu. If you have PC, then go to packages and install package. If you use Mac, then you're gonna choose package and the data and package installer, select the repository and select package. And yeah, or you can use the function install the packages and use library. Yeah, we have already talked about this part. Read SPSS, we also talk about this part. Yeah. Following package and read SPSS data. Yeah, these two functions are very important. Okay, so get WD, set WD. What is WD? WD is short for working directly. Get WD, just X R to tell, okay, where is the current working directory? So it will return the current working directory for you. If you are not good with that working directory, you can set your own, okay, set WD, and then give the specific folder inside the parentheses. Or you can use the session, click the session and choose your own working directory. So these two are important. Yeah, read Excel data. We also have already covered this part. And if you want to some help, okay, then question mark for help and the parentheses. Okay, that's it. I think I have already go through all of these slides, and if you have time, you can just go through all the R commands, R script. Actually, I provide you some other information more information in the script. Yeah, just do the exercise if you have time. Get familiar with this R environment. Okay. Okay, so here I also provide you some lines to generate the data. Okay, so suppose you want to generate a sequence of data. This is how to generate the sequence. For example, from 0 to 5, 5.5. What does that mean? I want to create a sequence starting from 0. 0 is the smallest number. Maximum number is 5, increased by 4.5. So the sequence is called Y. You can highlight this part and click run. So check Y in the console. So starting from 0, and every time it increased by 0.5, 0.5 and 1, 1.5 and 2.5, stop at 5. So that's a sequence you just generated or created. You can also sample data. For example, this is your Y. I want to sample 5 numbers from this vector. Okay, so I just sample, randomly choose 5 numbers from this Y vector. So these are random numbers from the Y. Okay, so we just randomly choose it. And if you make the option of replace equals true, that means every time that value can be replaced. Okay, so can be repeated. Okay, so you do it again. So 0.5 is taken twice. Okay, 2 is also taken twice because the replacement equals true. So this is another way to sample your data. Generated random numbers. Okay, so if you want to generate some random numbers, it depends on your distribution. Okay, if you want to get number from uniform distribution, then you can try to use R uniform. Okay, so that's it. So these 5 numbers are taken from the uniform distribution. The minimum value is 1, minimum 0, maximum is 1, and all of these are 5 random numbers from the uniform distribution. Also, you can take it from normal distribution. Okay, then that's normal. Standard deviations 2 means 1. Okay, 5 numbers. Or binomial distribution. Okay. Okay, so or some other F distribution or chi-square, it depends on your value. Okay. Any questions so far? Okay, I just give you a very basic introduction of R. R is very important. Okay, so if you are not familiar with R, then this method will be not easy for you. So get familiar with R, and also for other courses. Okay, it's very powerful. It's very popular. I hope that everyone can master R, and if you want to get a job in the academic, R is really important. Okay. For industry jobs, maybe SAS or maybe M+ is more important, but for academic positions, R is more important than the other commercial software. Okay. Question? Okay, today's course is really basic. Okay, so I can see that most of you get bored because because most of you are very familiar with this software. Okay, so I'm sorry. So I have to make sure that everyone can use R. So next week we are going to use SEM to do the data analysis. Okay. So question? Okay, then that's it. Okay. That's today's course. Thank you. Oh, really?
Yeah, so
Let me see. Package install.
install. You're gonna install it first. Is it there
No,
already? No.
that's what I'm saying, I can't find it.
So that's why you need to install it.
Well, I've
Because-
already installed 4. I installed 4 already. I didn't put it. So,
And Louis,
No, but I usually have
hold on, let me find it.
oh, you're like,
I mean,
My team just started Christmas and moving. I forgot how to put it on my culprit, so I want to go through it like submit it again. Like,
But that's for foreign, not SEM.
right,
But now
yeah,
it's
and even here, I search SEM. And that's all that comes up when you search SEM.
Yeah,
So-
you're gonna change it to SEM. Yeah, if you just install, not install first, install package SEM first. First step, install. Second step, library. Yeah. Yeah. SEM. Yeah. And the library SEM. Yeah, that's good. It's installing. Yeah. And yeah, bye. Yeah. And you will see the SEM package there.
I'm used to just being able to find it over there
Mhm.
using the name.
Let's see.
See, I was trying to do this, so I wouldn't have to wait next class period. and
Okay,
stuff.
that's good. That's good. Yeah, sure.
All right, awesome. Thank you very much, man. I'm sorry to
You
bother
said you want to let me know after the today's class. You said something. I asked you, okay, in the beginning, I asked you, how are you doing? You said, I will let you.
Oh, I was just being a smart ass. Don't worry about that.
I thought you have
No,
some
no, no,
story.
no,
to-
no,
Okay.
no. I was just being a smart ass. Don't worry.
Okay, is that done? No, because there's a red
Right.
stop sign is the
Yeah,
red
it's
stop sign.
still
Yeah,
loading
it's still loading.
So,
Yeah, it's quite a big package.
yeah. So you want more eggs?
No. I'm fine. I'm fine. Yeah, thank you so much.
Yep. No, I give eggs away every day.
I'm
So,
fine. 50 chickens, that's, how do you
we
feed
actually
them
just
every
got,
day?
huh?
How do you feed them every day?
Oh, no, I'm bad. I'm lazy. I have a 5-gallon bucket with things that they can stick their head in, and I just fill it up once a week. So when,
Okay, that's
so
good
on the
idea.
weekends, me and the kids, I've got a 55-gallon drum of water. that-
Oh,
They go out and they drink as they need. So every
I see, I
Saturday,
see, I
me and
see.
the kids go out, fill up all the feeders and all the water, and that's it.
Wow.
We go collect
that's-
eggs every day, and that's it.
there's something wrong? Okay, it
That's
should
just
be
saying where
okay.
it's at.
Yeah, just
So,
use, yeah, and then check the library, it's there. SEM, it's there.
okay.
Yeah, now it's
So-
installed. Yeah,
So,
good, good.
okay.
Yeah.
All right.
Thank you for making these fonts so large, because in the very beginning, I just, yeah,
Well, but and over there in your
Yeah.
viewing window, you can't really increase that, unfortunately.
yeah, thank you. Yeah, thank you for having me.